Hi, hello everyone. Welcome all of you to the Engineering Lectures Ali channel. Uh, I request all of you kindly like and subscribe this channel so you can receive all the updates from this channel. Thank you. Today we will talk about the movement. Movement is basically the normally the tendency of a force is to move a body in the direction of application. But in addition to this, a force can also tend to rotate a body about an axis. So the rotational tendency of a force is known as moment of the force. Moment is also known as torque. And basically what is torque? The rotational effect of force measured by a quantity is known as torque. The axis may be any line which neither intersects nor in parallel to the line of action of the force. Consider the pipe wrench. Force is applied perpendicular to the handle of the wrench. Is the tendency to rotate the pipe about its vertical axis. The magnitude of this tendency depends on both the magnitude F of the force and the effective length D of the wrench handle. Common experiences show that a pull which is not perpendicular to the wrench handle is less effective than the right angle pull shown. Movement about a point. Let a force F acting on a two-dimensional body in its plane. Movement about OO or Z-axis is proportional both to the magnitude of the force F and to the moment arm D. So movement is basically force into displacement, or you can say that force into perpendicular distance. The direction of movement vector m is always perpendicular to the plane of the body. The sense of m depends on the direction in which f tends to rotate the body. What is right-hand rule? We represent the movement of f about OO as a vector pointing in the direction of the thumb, with the finger curled in the direction of the rotational tendency. Movement direction may be accounted positive for a counterclockwise movement and a negative for a clockwise movement, or vice versa. This is by convention. We can take counterclockwise as positive. What is clockwise and counterclockwise? For example, imagine that the direction of clock, like 12, 1, 2, 3, 4. This is clockwise movement, and in the reverse direction like 12 to 11, 11 to 10, this is counterclockwise. Cross product or vector approach. The moment m of the force F about point A may be represented by a cross product, where R is a position vector which runs from the moment reference point A to any point on the line of force F. So moment is equal to R cross F. You can say M is equal to Fr sine alpha is equal to Ft. Reingen's theorem. The moment M of a force F about any point is equal to the sum of moments of the components of that force about the same point. Let R is equal to P plus Q. So R cross P is equal to R cross into P plus Q. This is an explanation of the theorem. Like M naught is equal to R cross P is equal to R cross P plus R cross Q. This is the simple problem. Calculate the magnitude of the moment about the basic point O of the 600 Newton force in 5 different ways. Like we can see that moment is equal to force into displacement. We can draw the free body diagram, and first we can calculate this T. About point O we are going to calculate. So we have make this triangle. We have known two-sided 4 meter and 2 meter. So now we are going to calculate the T. D comes out to be 4 cos 40 plus 2 sin 40. How this comes 4 cos 40? We can draw its component, and we know that the force is resolved into two components because it is applied on some angle. So we have resolved into its component, and we can calculate the D that's come out to be 4.35 meter, and movement is equal to force in displacement. The force value is given 600 Newton. So we can multiply it with the D, and we will come out to be the movement. So keep watching and subscribe this channel. In next videos we are going to discuss some of the more topics. Thank you.